This is the first video for our exploration into chapter 5, which deals a little bit more with the trigonometric functions, graphs, and we start working into solving equations and whatnot. There's a lot of things about solving equations that you have to sometimes to deal with when you're dealing with trigonometric functions. One of which is dealing with the inverse trigonometric functions, which is the first thing we are going to talk about here. So, as you recall, that we have our trigonometric functions. I mean, a typical sine functions graph would look something like this. If you were to take, like, each possible angle, take its sine and plot it accordingly, where your x-coordinate is the angle measurement, the y-coordinate would be the value you would get from performing the sine function. We're going to talk more about the periodic nature of this as we move along through this particular lesson, and talk more about it, particularly in chapter 6 as well. But we want to be aware of the fact of this is that, when I start trying to solve equations, if I'm looking for like the value of x that would produce a certain value for a sine, theoretically I have an infinite number of answers. So we want to keep that in the back of our mind, because what we may need to do in some cases is simply provide a rule that would establish or allow you to calculate all the possible values of x that would fit a certain category. But you can see it's a repeating pattern. It repeats every 2 pi, which also we kind of know, because I mean, if I go 2 pi, which is a full circle, I'm back to the same position, and that deals with coterminal angles. We know that for coterminal angles, the trigonometric function values are all the same. In a very similar nature for cosine, cosine functions graph looks like this. So again, we're going to spend more time talking about some other general characteristics, differences, and similarities between them as we move along. But it also has a period of 2 pi, meaning that if I complete a full circle, I'm going to have coterminal angles again, and therefore, the trig function values will all be the same. A tangent function is a little different. It's not a continuous function, first off. If you notice, it does have some asymptotes. And it also only has a period of pi. And that kind of goes along with the fact, if you remember from when we were talking about the pattern, about, we called it all suckers take calculus. Tangent is positive in the first and third quadrants, while it's negative in the second and fourth quadrants. So I don't necessarily have to always move a full circle before I start repeating that pattern. So that has a pattern in and of itself that lets me repeat more frequently. Whereas if I do the same thing with a sine or cosine, like a sine, I'd go from quadrant 1, it's positive. Quadrant 2, it's positive. Quadrant 3, it's negative. Negative in quadrant 4 returns back to positive. So I actually have to move to full quadrants before I get back to it being the same sign again. Whereas as I move from quadrant to quadrant for a tangent function, it goes positive, negative, and so forth, if I keep going around in a circle. So its period is only pi, and that affects some of what we do when we start solving equations as well. But one of the things we talked about, and we solved some very basic situations when we were dealing with solving triangles, we would employ the inverse trig functions, namely arcsine, arccosine, and arctangent. Also, I'm getting ahead of myself here. We do have asymptotes here for this, as I mentioned before, and basically that more or less means that we have some undefined values. So, like for instance, at pi over 2, remember the domain for the tangent of x, I'm kind of getting ahead of myself because I'm getting to the arc functions. But if I were to do like the tangent of 90 degrees, that was an undefined value. Same thing if I did 270 degrees or 450 degrees or anything of that nature. Any of those type of angles would produce an undefined value for tangent. Now, if I look at the inverse trigonometric functions just from a basic level of, what I would do to come up with that inverse, I would, switch my domains and ranges, and I would get a graph that looks like this. The problem is, it's not a function. Okay? It's the inverse, but it's not a function. It clearly fails the vertical line test in many ways, shape, form, and manner. But, since we have these trigonometric functions and we're going to need to have inverses of them, we need to have, an inverse that also produces a function. So in order to get around that, mathematicians basically stated, okay, well, for, the arcsine function, we're only considering that part of it. And very similar for, the inverse of a cosine function, we only consider that part of it when we deal with secant. And we look at the inverse of a tangent function, we're only dealing with this part of it for the arctangent. And that's why you're going to notice whenever we talk about these particular inverse trig functions that they have a domain, because the domain is just going to represent the range that the graph usually had for, the trig function itself. But I'm going to have a restricted range in order for it to be truly considered a function. This has some issues whenever you're dealing with solving equations, especially if it's circumstances where you're solving equations where special angles that you're supposed to know your trig function values for. And those trig functions you're supposed to know, you need to know them forwards and backwards now. Because you're going to need to know, well, if I have an angle, I see the sine of it is 1/2, what angles am I talking about? You should be able to come up with, that based off of your knowledge of your trig table. But if I end up with a fraction I don't usually see on my trig tables, like, okay, well, the sine of this is 3/5, well, I'm going to have to use my calculator, and the calculator is programmed with these ranges. And so when you deal with situations where you have to use your calculator particularly, it's going to produce, a value in that range. Meanwhile, that's not the only possible angle that would produce a value of 3/5 if I take the sine of it. So you have to be aware that there are other answers out there, and you have to know how to go about finding them. And that's what a lot of students fall short on this when they start making some critical errors, is that they just take what the calculator gave them, that's it, they finish it up. Meanwhile, that's one of many possible answers that you are responsible for finding.